Hey guys, welcome back. This is Aditya. In this video, we are going to see backpropagation. What is backpropagation? How the error gradients are computed. So if you're wondering why this video is presented in English, then I want to tell you the reason. The reason is because I couldn't find any good videos on the internet explaining backpropagation. I can find videos saying that backpropagation is just computing the gradients from the output layer to the input layer, but they're not explaining how actually the gradients are computed, how they are actually doing the mathematical derivations of the derivatives. So in this video we are going to see backpropagation in depth, so that you don't need any other video explaining backpropagation. So if you watch this video, you will get the intuitive idea behind backpropagation. And I find that many professors find backpropagation to teach difficult, they find it difficult to teach backpropagation. So this video will make all the concepts clear, right? So I want this video to be in English because there are a lot of machine learning and deep learning practitioners around the world. I want them to understand how the backpropagation actually works. So let's get into the video without much further ado. So I hope that you guys have a basic idea about what is backpropagation and neural networks. So a neural network is it's a part of deep learning. So what we generally do in backpropagation. So generally what we do in backpropagation is that I will give you an idea about backpropagation with an analogy. Let's say there's a company, right? There's a company, and a customer raises an issue about a product that the company manufactures. So let's say a customer goes to the CEO of the company and tells that there is an issue with the product. So what will the CEO do? So CEO will ask the manager, and what will the manager do? So manager goes to the next junior level manager, and what will the junior level manager do? Junior level manager will go to the developer. Let's say the company is a software company, so he will go to a developer, and the developer will go to a junior developer, and so on. So the junior developer then rectifies the errors, the mistakes, and then the junior developer will actually tell the senior manager that the errors have been rectified, and the senior manager will tell the CEO or the manager the errors have been rectified, and the manager will tell the CEO that the errors have been rectified, and then the CEO will contact the customer and will tell that we have fixed the bugs. The customer will be happy, right? So basically what we are doing, we are going from CEO to the employee, and then employee to the CEO. So this is the same thing is happening in the backpropagation, right? So I will explain you in detail. So see this x1 and x2 are the input layers, okay? X1 and x2 are the input layers, h1 and h2 are the hidden layers, and o1 and o2 are the output layers, okay? O1 and O2 are the output layers, and you can see this W1, W2, W3, W4, W5 till W8. These are the weights, okay? And this T1 and T2 are the errors, okay? T1 and T2 are the errors. So error in this layer, this level, and the error in this level. So the total error would be the sum of T1 and T2, right? So I hope this makes sense. And you can see this out of O1. Out of O1 is nothing but the sigmoid of O1. So I hope that everyone knows sigmoid. What is a sigmoid function? Sigmoid function is nothing but a logistic function. So we use sigmoid function as an activation function in this neural network, okay? So we use sigmoid function as an activation function. So that is O1. So sigmoid of O1 is this out of O1, right? I hope this makes sense. For example, if you compute the sigmoid of H1, which is the hidden layer 1, then it is called out of H1, right? Out of H1. So this is the initial neural network. So let's do backpropagation now. So as I told you before, what is the total loss? Total loss is the sum of the two losses, which is T1 and T2. So let's compute the loss, T1 loss and T2 loss. So out of O1 is the output of the neural network. T1 is the expected T1 is the expected output. But out of O1 is a predicted output. So we can just subtract out of O1 from T1, right? We can just subtract the predicted from the expected output. That is what I have done here. T1 minus out of O1, the whole square, plus T. This is actually T2, okay? This is T2. T2 minus out of O2, the whole square. I have computed the squared losses, right? Sum of the squared losses is equal to the total loss. I hope this makes sense, right? So now let's compute the gradients. So gradients. And I want to make this thing clear. So this is basically, in this backpropagation, we are not actually updating the weights, right? So in this video, I'm not explaining how to update weights. Actually, the reason why we do backpropagation is to update weights, but I'm going to explain how the gradients are computed, right? So we all know that how to update weights. That's very simple. So how do you update the weights? Let's say you are updating weight, which is the new weight. New weight is equal to old weight, right? Old weight minus the learning rate, which is the n, which is the eta, into the gradient. So in this video, I'm just going to explain like how to compute this gradient, right? How to compute this gradient. So now let's compute the gradients. So first I'm going to compute the gradients for this this layer, which is w5. For w5, I'm going to compute the gradient. So let's see how I can compute the gradient of w5. So so to compute the gradient, so we compute the loss gradient with respect to that particular weight, right? So that's what I've done here. This is this is the gradient of this is the derivative of loss function with respect to the w5. So this can be written as derivative of loss function into out of O1, which is this thing, right? This thing out of O1. All right, and this can be written as loss function, derivative of loss function with respect to out O1, which is the sigmoid of output layer O1, and sigmoid of this is the derivative of out of O1 with respect to the output layer O1, and into the derivative of out of O1 with respect to W5. So this is basically chain rule. Okay, this is basically chain rule. This can be written like this. So if you see this, you will understand it better. This is basically chain rule. Okay, this is chain rule. I hope this makes sense. So if you have studied about derivatives in your higher secondary, then this will be very easy. This is chain rule. So if you observe this clearly, you can just see what I have done here. So this is the loss, this is the loss, this entire thing is the loss, right? This entire thing is the loss. So loss is equal to del L by derivative of loss with respect to out O1, and out O1 derivative with respect to O1, and O1 derivative with respect to the W5. So basically this is how I have traversed backward direction, right? It makes sense, right? Backward direction. So this is how I will compute the derivative of W5, and we can see further. I mean, moving ahead, look at this. This is the loss function with respect to the out of O1, which is nothing but I've just computed the same thing again. I've computed this part, okay, basically this part. All right. So we all know that the loss is nothing but the loss of T1 plus T2, the sum of the total T1 and T2, right? So that's what I have done here. So taking a derivative, I get this answer. So how I am getting the answer? So I have done this derivative part. Look at here. So this whole square, this square thing will come here. This will come here, and so 2 will get cancelled, and I am doing the derivative. I am computing the derivative with respect to the out of O1. So this will be like this. We are doing the partial derivative, right? So this will be like this, and this will get this part will get 0. This part will become 0, right? So we will get the answer as this. This is our answer. All right. So this is our answer. All right. So next, moving ahead, let's compute this thing out of O1 with respect to out of O1 with respect to the output layer. So look at here. So this is the answer for this. All right. So how did I compute this? This is nothing but what is out of O1? Out of O1 is the sigmoid of O1, right? Sigmoid of O1. I just now explained that out of O1 is a sigmoid of O1. So this expression. Look at here. This expression is nothing but this is the derivative of sigmoid. Okay. So I have explained here. Look at here. So this is the sigmoid differentiation. So we all know the function, sigmoid function. This is the sigmoid function. So differentiating the sigmoid function, you will get this as answer, right? So this is all some simple simplification steps. So at the end, you will get this as the answer, right? This as the answer. And now I have considered this 1 plus e power minus x as this sigma. In turn, I can write this equation as like this, right? So this is actually equivalent to this, right? This thing. I hope this makes sense, right? So it's as simple as that. And now let's compute the last thing. which is derivative of output layer 1 with respect to W5, right? So if you look at this diagram, look at this neural network diagram. So you can see that we can write output layer 1, I mean O1, we can write O1 as H1 into W5, right? H1 into W5. Look at here, H1, because H1 and W5 is contributing to output 1, right? We can write O1 as H1 into W1. H1 into W1. I hope it makes sense, right? W1. So that is what I have done here. Look at here. So we can write it as out of H1. Out of H1 is nothing but the sigmoid of H1, right? Out of H1 into W5, because I have written it as out of H1 because this is out of H1 because we are actually concerned about the output of H1, not the H1. We are concerned about the output of H1. Output of H1 into W5 is the O1, right? So that is why I have written it as like this. Now if I compute the derivative, this W5 and this W5 will get cancelled because this is the partial differentiation, right? So then I will get this output out of H1 as the answer. So if I combine all these three equations, the derivative of W5 is this whole equation, right? This whole equation. So similarly you can calculate for W6, W7 and W8, because it's very similar to W5, because you can see here this W6, W7 and then W8 are in the same level, right? So it's very simple to calculate W6 and W7, W8 in the similar way as we computed W5. Hope it makes sense, right? So now let's compute for W1. Where is W1? W1 is here. W1 is here, right? W1 is here, which is actually next to the input layer, right? So let's see for W1. So look at here. So for W1 we can calculate like this, okay? So this is for W1. So for loss function with respect to W1, it can be written as derivative of loss with respect to out of H1 into derivative out of H1 with respect to H1, derivative of H1 with respect to W1. We can write this is also basically a chain rule. So let's say this has 1, this has 2 and this has 3, okay? So now let's compute for 1. We can't actually directly differentiate the loss function with respect to out of H1. So I am splitting this as like this, okay? So I am splitting like this. Observe this carefully, you will understand, right? So I am splitting like this. I am splitting like this because I have told you that loss function is the summation of the loss at one layer and loss at another layer, which is T1 plus T2. That's why I have split it like this, right? I hope this makes sense. This is basic, this is common sense. So I can write this this derivative derivative of T1 with respect to output of H1 as like this, right? Which can be further divided like this, and this thing can be divided like this, okay? Looking at this you will understand, right? So I can write derivative of T1 with respect to O1 as like this, and if I compute this I will get this as answer, okay? This as answer. I hope this makes sense. All right, and let's moving ahead. For this derivative I'm computing here. Look at here. This is the derivative of O1 with respect to output of H1. So look here. Where is O1? O1 is here. O1 is here. So I can write O1 as W5 into output of H1, right? W5 into output of H1. So this is output of H1. I mean, this is the output of H1, and this is W5. W5 into output of H1 is O1, right? So that's why I've written it like this. All right. So doing the differentiation, this output of H1 and output of H1 will get cancelled because this is partial differentiation, and W5 will be intact, right? And for this second thing, now let's compute the derivative, which is which is the differentiation of output of H1 with respect to H1. So what is output of H1? Just a second. So alright, so what is output of h1? Output of h1 is nothing but a sigmoid, right? Sigmoid of h1. So sigmoid of h1 with respect to that h1 we can write it as like, right? I've just explained you like that sigmoid differentiation clearly, right? It's as simple as that. And computing the next derivative, which is the third one, which is the differentiation of hidden layer 1 with respect to w1, right? With respect to the weight 1. So h1 can be written as, look at the diagram. So look at the diagram, h1 is here, h1 is here. h1 can be written as x1 into w1, x1 into w1, x1 into w1. I hope it makes sense, right? x1 into w1 is equal to h1, which is the hidden layer 1, right? So that's what I've written here. Just look at here, x1 into w1. So if you differentiate this x1 into w1 with respect to w1, and then this w1 and this w1 will get cancelled because this is the partial differentiation. This x1 will be intact, okay? So the answer is x1. So combining all these three equations, you will get this larger equation. Look at here, look at this. And I forgot to tell you one thing. So here, if you look at here carefully, this loss function with respect to output of h1 was written like this, was written into two equations, right? So for this differentiation of t1 with respect to output of h1, I have computed here, which is this big equation, right? This big equation. For this thing, for T2, I didn't compute. I've computed, but I didn't explain it here. You can just try computing. So for T2, the answer will be this, okay, which is similar to T1. Look at this T1 equation. Look at this T1 equation and T2 equation. There is a small change. You can understand the small change, right? We have just changed these variables. E1 as E2, and output O1 as O2, and W, instead of W5, this will be W7, right? If you go through this logic, you will understand why W7 has come, right? So combining all these three equations, we'll get this as answer. So what is the first equation? The first equation is this one. Look at here, this is the first equation, okay, this is the first equation, and this is the second equation, right? And this is the third equation, x1 is the third equation. So combining all these three things, we get this larger equation. Look at here, this is a larger equation, right? So this larger equation is the answer. So what is the derivative of loss function with respect to w1? This larger equation, right? So similarly, you can compute for w3, w4, and for w5. w3, w4 and w5 lies in the same level. I mean, see, w3, w2, w3, w4 are in the same layer, right? So similar to the w1, how we computed the gradient of w1, you can compute the gradient for w2, w3 and w4. I hope this makes sense. And I have a question for you. Alright, I have a question for you. Just a second. So alright. So I have a question for you, because this question will make your concept clear. Let's say like this is the hidden layer 1, okay, this is the hidden layer 1, okay, and this hidden layer, okay, this hidden layer 1's error is propagated, which is output of h1, okay, this is output of h1, this is out of h1, this is output of h1, this output of h1 is propagated to 3. This output of h1 is propagated in 3 directions, right? 3 directions. But if you look at this diagram, diagram which I explained, this output of h1 is propagated in 2 ways, 2 directions, right? 2 directions. So here I am saying it is propagated in 3 directions. So if the error is, if this output of h1 is propagated in 3 directions, will our equation change? This is the question I want to ask you. Will our equation change? Will our entire equation will change? Will our equation will change? Yes, obviously our equation will change, because we are propagating the error in 3 directions, not in 2 directions. For 2 directions, this equation is right. This equation we just derived is right. For 3 directions, the equation will change. Okay, this is one thing that you should remember, because most of my friends who learn backpropagation think that this is actually a formula, right? Most people just mug up this and they think that this is a formula, but I would say that this is not a formula. This is basic differentiation. So if the based on the diagram, based on a neural network diagram, you have to compute the derivative. Okay, based on a neural network diagram, you have to compute the derivative, and based on the derivative, you have to compute the new weights. Okay, there is no specific formula for backpropagation. This thing you have to keep in mind, because I can see many of my friends who study backpropagation think that for example, we have computed for W1, right? We have computed this entire derivative for W1. They think that they have to mug this W1, they have to mug this thing, and they think that this is a formula. This is not a formula, this is the derivative, and for different diagrams the derivative will change. Okay, so it's as simple as that. So I hope you understood like how the backpropagation is computed, and I will also attach this PDF in the description. You can go check out, and please understand how this is working. Please understand how the gradients are computed. Don't be like don't say that you know backpropagation without knowing how actually the mathematics is working here. You can't say that you understand backpropagation without understanding the mathematical part. Understand how we differentiate, how the derivatives are computed, how the errors are forward propagated and back propagated. Only then you can say that you understand backpropagation. So I hope this video made everything clear. So if you like this video, give it a thumbs up. Do subscribe to the channel. Do share this video to everyone that you know who wants to learn backpropagation and machine learning. So thanks for watching. We'll see you in the next video again. Until then, bye.